any area. Suppose this one is a circle and plus q charge placed at the center. Plus q charge placed at the center. How much flux passing through this circle? We know that general formula phi is equal to q enclosed upon epsilon naught. Q enclosed upon epsilon naught. Okay, means a complete circle. How much flux passing through this area? This is equal to simply q by epsilon naught. Okay, suppose you can take only half area of this one. Half area of this one. Here, q charge is placed. How much flux passing through this area? Phi is equal to, yes, complete circle flux q by epsilon naught. Now this one is a half circle. How much flux passing through this region? This is how much flux passing through this area? Complete q by epsilon naught. Okay. Now here this one is a half part. And how much flux passing through this one? May I audible?
Q by 2 epsilon. Yes, sir.
Okay. A complete part 100%. This one is a half part. Then q by 2 epsilon naught. Q by 2 epsilon naught. Yes sir? Q by 2 epsilon naught. Next. Suppose we can take the bowl. Okay. So, or here is a suppose this one is a complete spherical system. We can place q charges here. Q charges here. How much flux passing through this one? Yes. How much plus? Here this one is a sphere like that, a ball, and we can place the q charge at the center. Then how much flux passing through this sphere? Simply phi is equal to how much? Q by epsilon naught. Q by epsilon naught. Next, we can take the half part of this one. Half part of this one means system behave like a ball. Okay, particle is here. How much flux passing through this ball? From this bowl, how much flux is passing?
Q upon
Total q by epsilon naught. Now this part is half part, then q by 2 epsilon naught.
by 2 epsilon naught.
Yes or no? Or how to solve this one? Simply see here. Flux phi is equal to given divided by total into q by epsilon naught. Okay. Given upon total into q by epsilon naught. Given how much part? One part. Okay. Given one part. We need to, how many such a surface we need to cover this particle or the charge? असे किती पार्ट्स लागतील हे कव्हर करण्यासाठी? Given as well as remaining. Given 1 and again we need 1 means total 2. Yes or no? Total 2. Available 1. Hence we can take 1 by 2 is here. Here we record how many parts? 1 part. Given 1. Available 1. Okay, and total also we need 1 means 1 by 1 is equal to 1. Here the charge plus q charge is placed at the center. Okay. Here this is a 50% part is available. We need to cover this part. We need how many these circles? 2 circles. The half circle again we need to again 1 half circle means initial half and again second half means total 2. We need 2 half part, then we getting complete or enclose this part. Okay, yes, we can take here given 1 total 2 means here we can take 1 by 2. Got it? Next, suppose we can place charge at the center of the cube. Okay, how much flux passing through this cube? System is a cube. Okay, and we can place the particle or charge at center. Okay, at a center. Yes, at center. How much flux passing through this cube? The charge is enclosed, yes or no? The charge is enclosed. Enclosed. How much flux passing through this area? This is equal to simply Q by epsilon naught. Q by epsilon naught. Next, second one. Suppose we can place charge on surface of the ball, surface of the cube. Surface of the cube. How much flux passing through this cube? How much flux passing through this cube? How to identify? Here, this one is cube. Okay, particle place top of the cube. Top of the cube. How many cubes are required to cover this charge? We need how many cubes? किती cubes लागतील या केस मध्ये हा कव्हर करण्यासाठी? We need how many cubes? Yes. अजून एक लागेल. Yes or no? Total. Given one, again we need one. Yes or no? Means total required two. Then this particle is covered. Yes or no? Means here available. Here available one. Required two. Available one. Required two. Yes or no? Means here is a 1 by 2 Q by epsilon naught. Yes or no? Means we can place again one cube on this particle, this charge. Then this charge is covered. Yes or no? This charge is enclosed. Okay? Means here we require the two cubes. Means in two cubes, how many flux will be passing? Q by epsilon naught. Yes or no? In two cubes. Then one cube. How many flux will be pass? 2 cube, Q by epsilon naught. Then 1. 2 क्यूब मधून Q by epsilon naught जात असेल तर एका क्यूब मधून किती पास होतील? 200%. Then 1.
2 by 2 epsilon naught.
50%. Yes or no? Q by 2 epsilon naught. Okay, next. Again we can place charge at the center of the cube. Charge is placed at the center of cube. Okay. Center of the cube. We can place charge at the center of the cube. Okay. And there's how much flux passing through one surface? Okay. How much flux passing through one surface? Yes. How much flux passing through one surface? Total how many surfaces?
Q upon epsilon naught.
How many surfaces?
1.
6 surfaces. Yes or no? Total 6 surfaces. Then 100% flux passing in 6 surfaces. Okay. We need to find out only one surface. One surface given
6 epsilon.
Given 1. किती मधून फाइंड आउट करायचं? वन सरफेस. मीन्स गिवन इज 1. Total how many surfaces are present in this system? 6. Yes or no? Here is a Q by epsilon naught. Yes or no? Suppose a 6 amount of flux passing through this cube, then how much flux passing in one surface? टोटल क्यूब मधून 6 फ्लक्स पास होतील तर एका सरफेस मधून पास होण्याची प्रोबॅबिलिटी किती? 1/6.
Why, sir?
1/6. Okay. Suppose we can find out how many flux passing in two surfaces. Given how many surfaces?
1/3.
Given 2 surfaces. Available
2.
6. Q by epsilon naught.
6.
Given 3 surfaces. We can find out how much flux passing in 3 surfaces. 3 surfaces. Flux phi is equal to given 3. Available 6.
3/6.
Q by epsilon naught. Okay. I mean, this is how much? 1/2 Q by epsilon naught. Yes or no? 3 surface. Total 6 surfaces. 6 surfaces suppose 100% will be passing. Then From 3 surfaces, 50% will be passed. Yes or no? Means we getting q by 2 epsilon naught. Okay. In 5 surfaces, 4 surfaces, 4 surface. Given 4, total 6 q by 6. 5 surfaces. 5 is equal to 5 by 6 q by epsilon naught. Okay. Next 6 surfaces. 6 surfaces. How much flux passing in 6 surfaces?
Q by epsilon naught.
Flux phi is equal to given 6. Total required 6 q by epsilon naught. Okay. 6 is get cancelled. Q by epsilon naught. How much flux passing through this area is equal to how much? Q by. Next. System is again Q. We can place charge at one corner. Charge at one corner. Yes or no? Charge at one corner. How much flux passing through this cube? How much flux passing through this cube? Yes. How much flux passing through this cube?
1 by 8.
How much flux passing through this cube? Before of this one.
1 by 8 Q by
Find out how much cube required to cover this charge. We need how much cubes?
4 requires.
किती क्यूब घेतल्यानंतर हा चार्ज काय होईल? इनक्लोज होईल.
8 cubes.
1 cube, 2 cube, 3 cube, 4, 5, 6. Yes. Total
8, sir.
yes बोला 4 6 4 8. We required how many cube to cover this?
8, sir.
8 cube. Okay, first one,
8, sir.
second, third, fourth. Okay, fourth जर क्यूब असतील आपल्याकडे तर या 4 क्यूब मधून किती चार्ज आपला इन्क्लोज होईल या 4 क्यूब मध्ये? Half charge. Okay, and again we can place 4 cube here. Then 100% charge will be enclosed. Yes or no? Means here we need to require how many cubes? 8 cubes. Yes or no? Here we require how many cubes? 8 cube. Okay. We required how many cubes? 8 cubes. Okay. Then the charge is enclosed. Now, flux. How to find out the flux? Given we need 8 cubes to cover this charge. Yes or no? Now, available cubes. आता available cube is there. 1 cube is available. Yes or no? Cover the charge. We need how many cubes? 8 cubes. Yes or no? Means total 8. Available 1. Q by epsilon naught. Yes or no? Means 8 cube मधून जर 100% चार्जर फ्लो होत असेल तर एकामधून किती पास होईल? सपोज 100% 80% जर टोटल 8 क्यूब मधून पास होत असेल तर एका क्यूब मधून किती पास होईल? 10% or 1 by 8. Yes or no? Simply like that. Got it? Here is only 1 cube is there. We require 8 cube to cover the charge. Then the charge become enclosed. Yes or no? Means given upon total into q by epsilon naught. Same problem. Okay. In this case B. 2 cube. 2 cube. How much flux passing? 2 cube. Given 2. Total 8. Q by epsilon naught. Next. 3 cube.
3 by 8.
8 epsilon naught. 4 cube. 4 cube.
1 by 2.
1 by 2 q by epsilon naught. Okay. 7 cube. 7 cube.
7 by 8.
7 by 8 flux pi
7 by 8.
7 by 8 q by epsilon naught. Okay, 8 cube.
Only
8 cube means pi is equal to how much? 8 by 8 q by epsilon naught. Okay, 8 8 get cancelled. Here is only we getting q by epsilon naught. Flux pi is equal to how much? Q by epsilon naught. Got it? Next. We can place charges here. Place charges here. How much flux passing through this cube? In this cube, how much flux passing? Pi is equal to how much? Q by
Q1 is
8 epsilon naught. Okay. And suppose they ask how much flux passing in one surface. How much flux passing in one surface of the cube? Suppose this surface is 1, this surface is a 2, 3, 4, okay, 5, and this one is a 6. Okay. In what surfaces? In one surface. In one surface. Okay, system is this one. Okay. One surface. One surface.
1 by 6. 1 by 8.
आता एका क्यूब मधून किती पास होत आहेत? क्यू बाय 8 एप्सिलॉन नॉट. इन वन सर्फेसेस. आता या केससाठी या क्यूब साठी किती अवेलेबल आहेत? क्यू बाय 8 एप्सिलॉन. त्यापैकी एका सरफेस मधून किती पास होते?
1 by 6.
जर चार्ज सेंटरला असेल तर 1/6. ओके, पण आता अवेलेबलच किती आहेत? कॉर्नरला चार्ज आहे तर क्यू बाय 8 एप्सिलॉन नॉट. Then how much flux passing in one surface? आता अवेलेबल किती आहे तर क्यू बाय 8 एप्सिलॉन नॉट. येस ना? क्यू बाय 8 एप्सिलॉन नॉट. क्यू बाय 8 एप्सिलॉन नॉट. जनरली किती पास व्हायला पाहिजेत? अवेलेबल किती आहेत? क्यू बाय 8 एप्सिलॉन नॉट. आणि किती सरफेस आहेत? 6 सरफेसेस आहेत. तर एकामधून किती पास होण्याची चान्सेस? 1/6. ओके, मीन्स 1/6 इंटू क्यू बाय 8 एप्सिलॉन नॉट. 1/6 into q by 8 epsilon naught. Means this is like that. Q upon 48 epsilon naught. Got it? Like that. But this one is not correct. Why this one is not correct? Suppose they ask how much flux passing in second surface. Second surface. Okay. See here, suppose electric field in this direction. Okay, area vector in this direction. Flux 0 non-zero. This one is a E bar, this one is a A bar. Okay, E bar, A bar. Flux 0 non-zero. Non-zero. Yes or no? Flux phi is equal to E bar dot. E bar dot A bar. E bar dot A bar. Here angle is equal to how much? 0. Angle 0. EA not equal to 0. Okay. This is not equal to 0. This is equal to 0 possible if here theta is equal to how much? 0. Then this part is not equal to 0. Suppose theta is equal to 90. Then flux pi is equal to 0. Means at that time electric field in which direction? This direction. Area vector in this direction. Means area vector this direction. Electric field this direction. Angle between them 90. Angle 90. How much flux passing through this surface? 0. Yes or no? Means flux passing parallel to this surface. Flux passing to parallel to this surface. Then how much flux passing through this surface area? Suppose we consider this one is surface area, but electric flux in the direction. Electric flux in the direction. Then how much flux passing in this area? How much? 0. Yes or no? Because this flux is parallel to this surface, not toward you. Got it? And they ask how much flux passing toward you. Toward you, 0. Yes or no? Because this one is a parallel. This one is parallel. Means electric field in this direction and area vector is toward you. This we consider this one is area, then area vector is toward you. Area vector toward you. Electric field, the direction. Angle between them.
90.
Angle between them 90. Flux.
0.
Flux 0. Okay. Means angle between area vector and electric field is 90. Then how much flux passing through this area? 0. Got it?
0. Yes.
Suppose you can take this one as a charge. Okay, this one is a charge. Suppose we consider this one is a charge. Charge is here. Okay. Flux. Flux is scattered in all direction. Flux is scattered in all direction. Okay. In this direction, flux is going in like that. Okay. Second one, in the direction, flux is in the direction. And third one, here, flux is in the direction. Okay. Now, suppose we consider this one is the first, third. This one is the first surface. This is the third surface, and this will be. Suppose we consider fifth surface. First, third, and fifth. Okay. This surface is attached with this atom. Yes or no? This surface is attached with this atom. Now, flux in this direction. Flux in this direction. What is the area vector for this surface? Area vector in positive direction. Yes or no? Area vector is positive direction. Yes or no? Electric field in this direction. Electric field in this direction. What is the angle between them?
40%. Further 0.
See here. Suppose this one is a cube. This one is a cube. We can place charges here. Electric field is scattered in all direction. Okay. Now, here electric field, this direction. Here electric field, this direction. Here electric field, this direction, and so on. Got it? Now, suppose we can find out what is the electric field in this direction. Direction is this one. Yes or no? Electric field in this direction on this surface. Okay. Electric field, this direction. Area vector. What is the area vector of this surface?
Perpendicular to the surface, towards us.
Toward you. Yes or no? Towards us. Area vector towards us. Electric field. Electric field in the direction. Yes or no? Electric field in the direction. Yes or no? This is direction of the electric field on this surface. This is the direction of electric field. This is the direction of electric field, and this is the direction of area vector. What is the angle between them?
90 degree.
Angle between them 90. Means how much flux passing through this surface area?
0.
0. Second one, we consider this surface. Electric flux passing in this direction. Electric field passing in this direction. Okay. And what is the area vector for this surface?
Above.
Area vector for this surface, upward direction. Yes or no? This one is the area vector direction. This is the direction of electric field. Direction of electric field. Direction of electric field, this one. Okay. Area vector, upward direction. What is the angle between them?
90.
Angle between them 90. Means how much flux passing through this surface area?
0.
Third one, we consider this surface. Okay. Electric flux, downward direction. Electric field in the direction. Yes or no? Electric field direction is this one. Area vector, normal to the surface. Area vector, normal to the surface. Then what is the angle between electric field and area vector? Angle between them 90. Then how much flux passing in?
0. 0.
How much flux passing in first area? 0. How much flux passing in third area? 0. How much flux passing in fifth area? For fifth surface? 0. Means first, third, fifth. In 3 surfaces, electric field, flux passing in this area is equal to how much? 0. Okay. Means here angle making area vector and electric field is 90. Means here flux 0 from this surface, 0 from this surface, 0. Okay. Next, charge is here. Charge is here. Now we consider this one is surface. This one is surface. Area vector in the direction. Area vector in the direction. And electric field this direction. Yes or no? Electric field this direction. Means electric field in the direction, area vector in this direction. This angle is equal to 90. Charge is here. This we consider this one is surface. Yes or no? Angle 90. Possible, not possible? Yes or no? Means less than 90. Less than 90. Less than 90 means some flux will be passing. Yes or no? Means from this area we are getting some flux. Means here flux pi is not equal to 0. Okay. Next, we can take the below part. Charge is here. Charge is here. Electric field in the direction. Electric field in the direction. Electric field in the direction. Okay. Means electric field in the direction. Area vector in the direction. Again, here also angle is not equal to 90. Angle is not equal to 90. Then flux pi is not equal to 0. Means from this area flux is not equal to 0. This area also flux is not equal to 0. Similarly, here also we can take the charges here. Okay. And flux is passing through this area. Okay. Means here again angle making is not equal to 90. Yes or no? Area vector this one. Electric flux, electric field direction this one. Okay. Got it? Means this is not equal to exactly 90 like that. And this is not exactly equal to 0 also. Okay. Means here making some angle. Okay. And this pi is not equal to 0. Means out of 6 surfaces, how many surfaces flux will be passing?
Only 3 surfaces.
Only 3 surfaces. Okay. How much flux available? Q by 8 epsilon naught. Yes or no? Because we need to cover this charge. We required 8 cubes. Okay. Out of Q by 8 epsilon naught, phi 1, suppose we consider phi 1, phi 3 and phi 5 are attached with charge. Yes or no? This surface is attached with a charge. Then flux pi is equal to, yes, phi 1, phi 3, phi 5. Phi 3
0. 1 by 3 into 1 by 8. Q1.
1. Okay, here is a 1, 3, 5. How much flux passing in? 1, 3, 5 surfaces. 1, 3, 5 surface is attached with a charge. Next, phi 2, phi 4, phi 6. Total Q by 8 epsilon naught. Out of Q by 8 epsilon naught, here is how many surfaces? 3 surfaces. Yes or no? How many surfaces? 3 surfaces. And we need to find out only 1 surfaces. Okay. 1 given 1 out of 6 or 3?
3.
Out of 3. 3 is no need to consideration here because here no any flux is passing in this area. Yes or no? It's only phi 2, phi 4 and phi 6. Only these surfaces flux is passing. Got it? Means phi 2, phi 4, phi 6. There is a 3 surfaces. Okay? We need to find out how much flux passing in one surface. Means we can take 1 by 3. We can take 1 by 3. But now available is not here Q by epsilon naught. Available is not a Q by epsilon naught. Available is how much here? Q by 8 epsilon naught. Q by 8 epsilon naught. Means this is equal to how much? 4 into 3. Q by 24 epsilon naught. Amount of flux passing in phi 2 surfaces, phi 6 surfaces. Got it?
Yes, sir.
How much? Q by 24 epsilon naught. Next. Again we can play charge on one corners. Okay. how much flux passing in this shaded region? How much flux passing in this shaded region? Okay. Total, how much flux are available here? किती फ्लक्स अवेलेबल आहेत या क्यू बाय 8 एप्सिलॉन नॉट. येस और नो? म्हणजे या क्यूब मधून टोटल क्यूब मधून किती फ्लक्स पास होतील? क्यू बाय 8 एप्सिलॉन नॉट. येस और नो? हियर 5 क्यूब is equal to how much? Q by 8 epsilon naught. Yes or no? 8 epsilon naught. And we can ask for how much flux passing in shaded region. Yes. Shaded region. Yes. Shaded region. Here, total how many surfaces are available for passing the flux? 3. Okay. Means write down here first. Total किती available है? Q by 8 epsilon naught. Yes or no? Q by 8 epsilon naught. Okay. This much amount of flux available for this cube. Next, out of this one, only 3 surfaces. This much amount of flux is passing. Okay. Means this become 1 by 3. Yes or no? म्हणजे एका surface साठी किती 1 by 3. For one surfaces we getting 1 by 3 into Q by 8 epsilon naught amount of flux. Okay. Out of 1, yes or no? Out of 1, here, shaded part.
1 upon 3.
1 by 2. Yes or no? This shaded region is 1 by 2 of 1 surfaces. Yes or no? Means here, total Q by 8 epsilon naught, only 3 surfaces is passing. Then we can multiply it by 1 by 3. Out of this one again, we can take only 1 by 2 parts. Is 1 by 2 into 1 by 3 into Q by 8 epsilon naught. Yes or no? This is equal to how much? Q by 48. Q by 48 epsilon naught. Q by 48 epsilon naught. Next. How much flux passing through this shaded region? Charge is here. This is how much part of one surface is? This part.
1/4 part.
1/4 part. And how much flux passing through this shaded region? I is equal to
1 by
yes.
4.
Huh?
1 by 4. 1 by 3. Q upon 8 epsilon naught.
1 by 4 into 1 by 3 into how much? Q by
Q upon
8 epsilon naught. Okay. This is equal to how much? Q upon 96 epsilon.
90.
Yes. In this case, any doubt?
No, sir.
सर कालचे स्क्रीन शेअर नाही केलेलं ना.
How much flux passing through this shaded region? How much flux passing through this shaded region?
Q upon 48.
0.
Epsilon naught. 0 sir. 0 sir.
0 कसं येईल?
परत एकदा दाखवा डायग्राम. झिरोच थर्ड मध्ये.
Yes, how much?
झिरो येईल ना सर?
झिरो सर.
इथं पण झिरो येईल सर सेकंड केस मध्ये. इथे पण झिरो येईल.
Flux pi is equal to.
झिरो.
Hmm? How much? Flux pi is equal to.
Q by 2 epsilon naught partial. Q by 2 epsilon naught.
Q by 2 epsilon naught. This one, Q by 2 epsilon naught. Okay. Next. Plus Q charge is placed at a by 2 distance. A by 2 distance. Okay.
सर सिलेंडरचं नाही समजलं. क्यू बाय टू ऍप्सिलॉन नॉट कसं काय आलं?
हा गेन क्लोज करण्यासाठी अजून एक सिलेंडर लागेल ना आपल्याला.
हो.
ओके, आता अवेलेबल किती आहे? 1 आहे. टोटल किती लागतील? 2. मीन्स 1/2. Suppose from x axis we can take place charge q at a by 2 distance. Okay, how much plug passing through this surface?
क्वेश्चन
Q
काय आहे सर?
epsilon naught is 8.
क्वेश्चन काय आहे?
a by 2 एवढ्या डिस्टन्स वर आपण एक चार्ज ठेवलाय, बरोबर आहे. तर आपल्याला या एका खालच्या सरफेस वरून किती फ्लक्स पास होतील?
ठीक आहे. एक्स वाय ऍक्सिस आहे का सर?
और एक्स वाय कन्सिडर करा. येस.
तर त्या दोन्ही सरफेस मध्ये Q by 2 epsilon naught.
किती पास होतील? How much amount of flux passing through the surface?
Q by 2 epsilon naught. कारण का ते
Yes, बोला. How much? Yes, how much flux passing through this region?
तर कसं
हा, तर या फेस मधून किती फ्लक्स पास होतील? How much flux passing through this space? या फेस मधून किती फ्लक्स पास होतील?
Q by 6. 6 का सर?
येस, क्यू बाय 6 कसं येतील?
ते क्लोज करायला चार्ज.
2 लागतील अजून की 4 म्हणजे टोटल 8 लागतील.
4 लागतील ना सर?
येस.
सेंटरला आहे.
हो, सेंटरला आहे. देन
तर 2 फेस दिले 2 लाख 4 लागतील ना सर?
बोला पटकन, किती लागतील? This one is a one surface. Yes, sir. This one is a one surface. Okay. How many surfaces we require to close this charge? Yes. 1, 2,
6.
3, 4, 5, and back 6. Yes, sir. Total how many we need surfaces? Because they are here. Given word is a face. Word face. Yes or no? This one is one face. Charge is here. How much faces we require to cover the charge? 1, 2, 3, 4, 5, and above 6. Yes or no? Means here, how many flux passing through the surface? Pi is equal to Q by 6 epsilon naught. Q by 6 epsilon naught. Got it? Next. Suppose this one is the area, okay, and flux passing in this direction. What is the phi here? Net flux phi. How much flux passing through this phi region? Phi total.
You enclose upon exclude not, na?
This is about like that, a pi incoming plus pi outgoing. Net.
0 येईल ना सर?
Net. How much?
0 येईल.
Net. 0. Yes or no? Net how much? Suppose system is like that. System is like that, okay? Flux is passing in this direction. Flux is passing in this direction. Phi total. Phi total. Phi total.
0.
Phi total is equal to how much? 0.
तर 0 नाही येणार, सरफेस आहे, क्लोज नाही आहे ना? क्लोज नाही. तर 0 कसं येईल?
Phi total incoming is equal to outgoing.
सर एन्क्लोज सरफेस आहे ना सर?
चार्ज कुठे इथं?
सरफेस आहे ना सर?
चार्ज अवेलेबल नाही इथं. चार्ज इकडे कुठेतरी आहे दूर. त्यावरून फ्लक्स येत आहेत आणि या फ्लक्स आपल्या या सरफेस मधून पास आउट होत आहेत. लक्षात येत आहे? हा इथे चार्ज नाही, इथे चार्ज असेल तर परत तो एनक्लोज होईल. आपण ओनली लाईन्स घेतल्यात. येस और नो? फील्ड येते या डायरेक्शनने. म्हणजे तुम्ही अजून जरी एक घेतली तर तरी हा काही एनक्लोज होणार नाही. चार्ज इकडे आहे. लक्षात येत आहे? Then how much flux passing through curved surface? How much flux passing through curved surface? किती फ्लक्स कर्व सरफेस मधून पास होतील? येस और नो? Phi total is equal to phi this surface. This one is Which type of surface?
Curved sir.
Flat surface. One is flat surface. One is curved surface. Yes sir. One is flat, one curved surface. They ask how much flux passing through curved surface. Our aim to finding the how much flux passing through curved surface. Okay. But we know that phi total is equal to
5 flat plus 5 curve.
phi flat plus phi curve. Then phi curve is equal to
0. तर my 5 curve is equal to minus 5 curve flat.
minus phi flat. Yes or no? Phi flat.
Yes, sir.
Okay. But we know that flux phi is equal to E bar dot A bar dot E A bar. E bar dot A bar. Yes or no?
Minus A.
Electric field direction. Electric field direction.
Curved sir. Curved sir.
Positive x direction. Yes or no? Electric field direction is positive x cap. E x cap. Dot. Area vector direction here. Flat surface. Area vector direction.
Y cap.
Minus x cap.
cap.
A minus x cap. Okay. And this will be curve. Yes or no? Circular. Circular area.
Pi r square.
E pi capital R square. Bracket complete. X cap dot minus x cap. X cap dot minus x cap. Minus 1. Minus into minus. Plus A into how much? Pi R square. Yes or no? Which how much flux passing through curved surface? How much flux passing through curved surface?
E into pi r square.
A into pi R square. How much flux passing through flat surface?
Minus E into no. E into pi, minus E into pi r square.
Pi flat. Pi
Minus E
flat
into
is
pi r
equal to how much? Minus A into pi R square. Hence total phi is equal to pi flat plus phi curve is equal to how much? Minus E pi R square plus E pi R square. How much? Minus plus get cancel. Then pi total is equal to how much? 0 for this case. Got it? They ask maybe pi flat, pi curve, or pi total. Got it? Next. Suppose we can take a cube and as well as also we can take one rod. Cube and rod. Rod means on rod have some charges. Yes or no? Charge is there. Then how to place a rod? We getting maximum flux and minimum flux. In which position we getting maximum flux and minimum flux? म्हणजे रॉड आपण कशा पद्धतीने ठेवल्यानंतर मॅक्झिमम फ्लक्स आणि मिनिमम फ्लक्स मिळतील. येस. In which position we getting maximum flux and minimum flux? Yes. Max flux and minimum flux. In which position? Suppose we can take a rod is horizontally. Okay. A rod horizontally. Then how many surfaces this flux will be passing? They are given linear charge density. Linear charge density on surface. Yes or no? Linear charge density. Linear charge density. A rod. Okay. Linear charge density. Linear charge density represented by lambda. This one, linear charge density lambda. Yes. Linear charge density lambda. Lambda is equal to how much? Lambda is equal to charge upon length. Length of the rod is suppose L. Then Q is Q upon L. Means Q is equal to how much? Lambda L. Q is equal to how much? Lambda L. And then plus pi is equal to Q upon epsilon naught. What is the value of Q? Q is equal to lambda L upon epsilon naught. Lambda L upon epsilon naught. Okay. Suppose we consider a rod length is A. Side of this cube is A. Side of cube is how much? A. Then here we can take L is equal to A. Yes or no? Means lambda A upon epsilon naught. Yes or no? Salil?
हो सर.
Okay, this one is a L. L is the length of rod. Similarly, this is a width is nothing but A also. Okay. Second one. Suppose we can place rod is like that. Rod is like that. We can place rod is like that. Flux pi is equal to Q by epsilon naught. Q by epsilon naught. And lambda is equal to how much? Q upon width. Q upon L. What is the L value here?
√3 by √3.
What is the L value here? This one is A. Okay, this is A. This A. In between.
√2a.
First one is this one is A. This become a root 2A. Yes or no? Root 2A. And the
Yes,
third
sir.
one.
आता काही
This is root 2A and this is A. Okay, this is equal to squaring of this one. This we are getting this length. Yes or no? Root 2A square plus A square means this become a root 3A side. Yes or no? Means lambda is equal to how much? Lambda is equal to root 3A. Lambda width is equal to how much? Root 3A. Means plus pi is equal to how much? Pi is equal to root 3A.
आपण epsilon.
Lambda upon epsilon naught. Okay. Means we can place rod is like that. We getting flux is equal to this one. We can place a rod is like that. We getting flux is equal to this one. In which cases we getting maximum flux and minimum flux.
सर ते मेन डायगोनल मध्ये मॅक्सिमम फ्लक्स मिळतो आपल्याला.
Lambda A upon epsilon naught is same in both cases. Yes or no? First case 1.
Yes, sir.
Second case root 3. Which value is larger?
√3 लॅम्बडा बाय एप्सिलॉन नॉट. म्हणजे डायगोनली मध्ये जास्त येते सर.
Diagonally we getting
हाय व्हॅल्यू.
maximum value. Why are we getting the maximum value? Here in this surface.
लेंथ इज
Here in this surface flux. In first cases, in this surfaces flux pi is equal to 0. In this surfaces flux pi is equal to 0. It's only 4 surfaces flux will be passing. But here, no any one surface we getting angle between flux and area vector is equal to 90. Yes or no? Means in second cases all surfaces flux is passing. Here only 4 surfaces flux will be passing. Yes or no?
येस सर.
Next.
सर आजचं व्हिडिओ पण लेक्चर पण आहे म्हणजे रेकॉर्ड होतंय सर आजचं.
Yes, yes.
ओके सर. सर ते कालचं केव्हा शेअर करणार आहात तुम्ही?
आज संध्याकाळी.
ओके सर थँक्यू.
Next, suppose we can say that disk. How much flux passing through the disk? Suppose we can place disk is like that. and charge q is here. Charge q is here. Flux direction is this one. Flux direction is this one. Area vector direction. This is the flux direction. Okay. Area vector direction. Area vector normal to the surface. This one is the surface. Normal. Normal to the surface means. This is called theta. Yes or no? This is dA bar direction. dA bar. This is the E bar. Okay. Means d phi is equal to how much? D phi is equal to. Suppose this axis is. We consider this is R. And this is Z. Then what is this wavelength? Under root Z square plus Z square plus R square. Z square plus R square. Then what is the electric field at this point? Electric field at that point. Electric field. K, charge, how much? Q. Upon distance square. What is the distance? Distance. Z square plus R square. Z square plus R square. Okay. E D A bar. E D A bar. Here angle is equal to 0. Here angle is equal to 0. This angle is equal to 0? No. This angle is not equal to 0. If this angle is not equal to 0, we can take EDA cos theta. Yes or no? Because theta is unknown here. Theta is unknown. This is equal to theta and this theta. Same. Yes or no? This theta, this theta. Then what is the value of theta? Cos theta.
Z upon root Z square plus R square.
Z upon Z square plus R square. Z square plus R square bracket is to 1 by 2. Yes or no? Z upon Z square plus R square bracket is to 1 by 2. Yes sir? Got it? This theta and this theta will be same. Hence we can take cos theta is equal to adjacent upon hypotenuse. Adjacent Z. Hypotenuse Z square plus R square. Bracket is to 1 by 2. Okay. Cos theta over E also over. Then what is the value of dA? dA system 1D, 2D, 3D. System 1D, 2D, 3D. Disk 2D. Length elements. In the direction length element dr. In the direction length element r d theta. Yes or no? Means what is the value of dA? dA is equal to r dr d theta. R dr d theta. Got it? R dr d theta. K constant variable, constant. Q constant variable, constant. Z constant variable, constant. Take common out. Integration 1 upon here 1, here 1 by 2 means Z square plus small r square bracket is to 3 by 2 dr into d phi. D phi limit. D phi limit 0 to 2 pi. Oh, d theta 0 to 2 pi. Here 0 to. Here Z is constant, R is variable. Center, R value 0. At end, R value capital R. Second integration value. First integration value. Yes. 2 pi kz 1 upon Z square plus R square bracket is to 3 by 2. How to solve this one? Yes. Nothing something. Here, this one is a nothing something.
Nothing.
समथिंग यूज करता येईल, नथिंग यूज करता येईल. नथिंग, नथिंग,
नथिंग करता येईल सर.
नथिंग, समथिंग. Here is this are going to here. इथं पुढे येईल ना. Something, nothing, something, something, nothing, minus 1 upon z square plus r square bracket is to 1 by 2 limit 0 to capital R, 0 to capital R. And this is equal to how much? 2 pi kz, 2 pi kz. Yes, interchange the limit. 1 upon z minus 1 upon z square plus r square bracket is to 1 by 2, bracket is to 1 by 2 sigma. Okay, we know that k is equal to 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, 1 by sigma upon 4 pi, pi get cancel, sigma by 2 epsilon naught, inside 1 minus z upon under root z square plus r square, z square plus r square. This much amount of flux passing through in which region? Disk region. Yes or no? Charge place is here. How much flux passing through this one? Yes, any doubt? Yes, or
No, sir.
okay. Next, infinite seat, infinite seat, infinite seat, infinite seat. How much flux passing through the infinite seat? Yes, infinite seat.
Sigma by 2 epsilon.
Infinite seat, we consider a cube is a seat. Okay, cubic system. Means Gaussian surface is a cubic. Gaussian surface is a cubic. Okay. Sphere. sphere, we can take spherical. Sphere as a Gaussian, okay. System is a cylinder, then we can take Gaussian is cylinder. Yes or no? This one is a Gaussian. Here, this one is a Gaussian. Got it? For infinite state, we can take
Cube.
cubic is an infinite state, okay. Charge is present on surface, yes or no? Like charge is here. Electric field direction, this one, yes or no? Electric field direction, this one. Here, area vector direction, this one, this one, this one, this one, this one. Total we getting how many areas? 6 areas, yes or no? Yes or no? Total 6 areas. Suppose you can say this one is the first, this one is the fifth, suppose. First, fifth. First one, area vector, this one. Electric field, this one. Angle between them. Zero. Angle between them, 0. Cos 0. 1. Cos 0, 1.
1.
Second, electric field direction, this one. Area vector, this one. Angle between them. Area vector direction, this one. Electric field, this one.
90.
0.
90.
Area vector.
Again 0, sir.
Area vector, this one. Electric field direction, this one. Angle between them, 90. 0. Second, 0. Third one, toward you suppose. This also, 0. Fourth one, back. 0. Say, fifth. Electric field, downward direction. Area vector, downward. Angle between them is equal to how much? Is equal to Q enclosed upon epsilon naught. Is equal to how much? Q upon epsilon naught. Yes or no? Got it? In this case, 4 area vector and electric field dot product is equal to how much? 0. Got it? Electric field upward direction and downward direction. Here we can take Gaussian is a cubic. Hence remaining 4 component getting 0. EA plus EA is equal to Q by epsilon naught. Yes or no? Q by epsilon naught. System 1D, 2D, 3D. System 1D, 2D, 3D. 2D. Then Q is equal to, sigma is equal to Q upon A. Then Q is equal to sigma I. Okay. Then this A get cancelled. E is equal to how much? Sigma by 2 epsilon naught. Why we can take here also A and here also A?
टोटल फ्लक्स पासिंग काढण्याचा असेल तर त्या क्यूबचा एरिया तेवढा घ्यावा लागेल सर.
दोन्ही पण एरिया कसे येतील? सेमच येतील. Yes or no? Because this one is infinite. Gaussian also infinite, body also infinite. As both areas will be same. Hence we can take this A get cancel. Is how much flux passing through this surface? Infinite surface. Sigma by 2 epsilon naught. Below also sigma by 2 epsilon naught. Total up and down.
सिग्मा बाय epsilon naught.
Total how much? Sigma by epsilon naught. Okay. Next. Suppose electric field in some region is found to be E bar is equal to K R square R cap. K R square R cap. Sorry, K R cube R cap. K R cube R cap. consider as a spherical coordinates. Spherical coordinate. Find the charge density. Find charge density. Find charge density. Find charge density. Find charge density. Next, find the total charge containing sphere of radius capital R. Second one, find total charge. Find out Q total. First, find out the charge density, and second one, we can find out the total charge. Okay. How to find out the charge density? What is the relation between electric field and charge density? Yes.
Del dot E is equal to rho.
Del bar dot E bar is equal to good. Del bar dot E bar is equal to rho by epsilon naught. Rho by epsilon naught. Yes or no? How to getting this equation? We know that close integral E bar dot ds bar is equal to Q by epsilon naught. Q by epsilon naught is nothing but Q by epsilon naught. Q is nothing but rho into d tau. Okay. This one is a surface integral. Surface integral is converted into volume integral. Del bar dot E bar d tau is equal to how much? 1 by epsilon naught. Rho d tau using which theorem? Using which theorem?
Gauss divergence.
Gauss divergence theorem.
Gauss divergence theorem.
Then rho is equal to how much? Rho is equal to epsilon naught del bar dot E bar. Okay. And in spherical system, we getting del bar dot E bar is equal to how much? 1 by r square. Dab upon dab r. R square E of r. Similarly, like that E of theta, E of pi. But here this part will be changing. Okay. Means what is the rho? Rho is equal to del bar dot E bar is equal to how much value? Don't take directly dab upon dab r. Kr square Q. Got it? We know that electric field can be written in the form of theta and pi, all of the terms, okay? But here we can take only r component, hence we can take here r. And this is equal to how much? Then 1 by epsilon naught, 1 by r square, dab upon dab r square, k r to the power how much? 3. K r to the power 3. R square k r to the power 3. Got it? हे आपण पाहूया नंतर. आता नाही वेळ आपल्याला हे पाहायला, पण हे डायरेक्ट फॉर्म्युले जे आहेत ते डायव्हर्जन्सचे आहेत, डेल स्क्वेअरचे आहेत. लक्षात येते जनरल घेताना काय करतो आपण? डेल इज इक्वल टू आय डब अपॉन डब एक्स लाईक दॅट, आय डब अपॉन डब आर अँड सो ऑन. ओके. पण या केसमध्ये डायव्हर्जन्स आहे. डायव्हर्जन्सचा फॉर्म्युला काय? 1 upon r square dab upon dab r square er. What is the er value? Er is equal to kr cube. K take common out. K epsilon naught r square. Sorry. K epsilon naught upon r square. R to the power 2, r to the power 3. Yes, r to the power 3, r to the power 2, r to the power 5. Dab upon dab r to the power 5. R to the power 5 derivative.
5.
R to the power means here charge density 5k epsilon naught r square. 5 k epsilon naught r square. This much amount of charge density will be created. Got it? Next. Into 5 k epsilon naught r square. Next, what is the total charge? Total charge and density relation. Density and charge relation. Q is equal to rho into system spherical d tau. What is the d tau value? D tau 5 k epsilon naught r square into 4 pi r square dr. Yes or no? Because charge density does not depend upon theta and phi. Hence we can take remaining part as a constant. Okay? Means we can take 5 k 4 pi r square r to the power 4 integration r to the power 5 upon 5. Why we can take capital R here? Why we can take here capital R? Because they ask for total charge. Yes or no? Total charge. From where to where? Center to radius of the body. Yes or no? This is आपला total charge जो असेल हा कुठपर्यंत इन्क्लोज होईल capital R पर्यंत. Okay? Means what is the value of QT? QT is equal to 5k. 5 get cancel. 5 get cancel. Means 4 pi k epsilon naught r to the power 5.
सर के ची व्हॅल्यू पण टाकू शकतो ना?
के ची टाकता येईल पण के आता इथं हा के म्हणजे 4 पाय एप्सिलॉन नॉट नाहीये, हा जनरल के आहे.
नाहीये ना?
Yes. Got it? Yes, any doubt in this case?
सर वो आप
हाँ. Yes.
वो कैसे
कौन सा?
आर स्क्वायर यार क्यों सब्स्टिट्यूट किया डेल डॉट ई की जगह पे?
अच्छा, वो जो है तो थोड़ा सा फॉर्मूला है, तो उसमें डेल बार डॉट ए बार एनी वेक्टर डेल बार डॉट ए बार इज इक्वल टू 1 upon h1 s2 s3 h1 s2 s3 dab upon daba q1 a1 h2 s3 s2
2
s2 s3
आपण डबल Q2
एंड सो ऑन. ओके, सिस्टम स्पेरिकल है हमारे पास, तो h1 s2 s3 कितने होते हैं? h1 s2 s3 इज इक्वल टू
r स्क्वायर sin थीटा
1 r sin थीटा. ओके,
r sin थीटा
और q1 q2 q3 क्या होते हैं? r थीटा phi. q1 q2 r theta and phi. Okay, what is the general formula here? Dab upon daba q1 a1 s2 s3. Okay, second dab upon daba q2 here a2, missing h2 here, write down here h1 s3. Similarly dab upon daba q3 a3 h1 h2. Okay, systems के हिसाब से h1 h2 s3 will be changed. Partition h1 h2 s3 1 1 1. System is cylindrical 1 rho 1. System is spherical 1 r sin theta. Okay.
r sin theta.
Suppose you consider the spherical system. Then this is equal to how much? 1 upon r square
sin theta.
Sin theta. Dab upon dab r. Okay. A1 means here AR. A1 means AR. And what is the H2 S3? H2 S3. S2 R sin theta. R sin theta.
r square sin theta.
R square. Sorry.
sin theta.
R square. R into R sin theta. But sin theta is not a function of. Sin theta is not a function of R. Then take common out. This
So
sin
we
theta
can take that
get
out.
cancel. We're getting 1 upon r square, double upon double ar. Okay.
Yeah.
A bar is any vector. A bar can be written as AR r cap plus A theta
Plus A
theta
theta
cap
theta
plus A
plus
phi.
A phi phi cap.
Got it. Like that here electric field. Electric field E bar is equal to ER r cap E theta theta cap plus E phi phi cap. Okay. Got it. Similarly,
Yes.
similarly for phi. Similarly for phi, 1 upon r square sin theta double upon double phi double upon double phi sin theta double upon double sin theta. Okay. Sin theta. Next problem. E bar is equal to AR cap plus B sin theta cos phi cos phi phi cap upon R. Find out the charge density. Here electric field is function of R and phi. Yes or no? R and phi.
Phi.
Means in this case, what is the value of ER? ER value.
Minus
ER
A by R.
A by R.
A
Not
by
only A by R. What is the value of E theta? E theta.
0.
E phi.
0.
B sin theta cos phi
B sin theta cos phi but
upon R. चलो. Find out first. आता फाइंड आउट करता येईल तुमच्याकडे ई आर आहे ई फाय आहे आणि तुम्हाला फॉर्म्युला पण नोन आहे. चलो कर फाइंड फर्स्ट. येस
किशोर सर.
हा बोला.
सर थोडस प्रिव्हियस स्लाइड दाखवतात का प्लीज.
बरं या केसमध्ये काय अडचण? इन दिस केस एनी डाऊट? See here. Here rho is equal to how much then? Rho is equal to r part 1 by r square double upon double r. Okay, into s r square. What is the value of ER here? ER is equal to A by R. ER is equal to A by R. R square A by R plus 1 upon R square sin theta. 1 upon R square sin theta. 1 upon R square sin theta into double upon double phi sin theta. What is the value of E phi? E phi is equal to B sin theta cos phi. B sin theta cos phi. Which part get cancelled? This sin theta, this sin square theta get cancelled. Here 1 by r get cancelled. 1 by r get cancelled. And double r upon double r 1. Means here is only we getting A upon r square. This sin square get cancelled. Cos phi derivative minus sin phi upon r square. And this is equal to how much? 1 upon r square. A minus b cos theta. A minus b cos phi. Yes, everyone got this?
सर वह साइन थीटा 2 बार क्यों लिया है?
कौन सा? ये वाला एक sin theta.
cos phi है ना?
Yes, ये वाला sin theta. H1 H2 वाला. 1 minute.
Yes sir, understood.
H1 H2. Okay, 1 minute. H1 H2. Sin phi. ये सगळे फॉर्मूले बाद में देखेंगे ना, मतलब del divergence, del square, gradient. Okay, gradient value also different for different cases. Okay. Next. Yes. 1 upon h1 h2 h3 means r square sin theta. R square sin theta. 1 upon r square sin theta. Okay. Next, dab upon phi. Dab upon phi. H1 h2 h1 1 h2 h1 1 h2 r into a phi into a phi. Good. Don't take here sin square phi.
सर थीटा का कंपोनेंट
थीटा का कंपोनेंट नहीं, क्वेश्चन में नहीं पूछे, इसलिए हमने नोट डाउन नहीं किया होगा। हमें ये प्रॉब्लम लेना था, इसलिए हमने फर्स्ट और लास्ट ले लिया। Got it? Means here, what is the a phi value? Sin theta cos phi. Sin theta cos phi. Sin theta cos phi. Okay. And this sin phi, sin theta get cancel. Got it? हमारा एक r जो है वो भी शायद कैंसिल हो जाएगा। ठीक है, ये r कहाँ कैंसिल हो जाएगा? ये जो r है, ठीक है, ये r और ये डिनोमिनेटर वाला r वो कैंसिल हो जाएगा। समझ में आ गया आपको? वन r यस, ये r और ये r कैंसिल हो जाएगा और बाहर वाला जो r स्क्वायर है तो वैसे ही रहेगा। आगे समझ में?
यस सर।
Next, potential. Electrostatic conservative system. Potential. Electrostatic is a conservative system. Yes, electrostatic is a conservative system. Electrostatic is conservative system. Electrostatic is conservative system. Conservative system. Okay. We know that system is a conservative curl. Force is conservative. Then curl of a bar is equal to. Force is conserved. Force is conserved. Okay. Force is conserved. Curl of a bar is equal to 0. Similarly, yes. Similarly, yes. Curl of E bar also. Curl of E bar is equal to 0. Curl of F bar is equal to 0 implies that F bar is equal to negative gradient of scalar function. Yes sir, negative gradient of scalar function. We know that DCV and CGS, DCV divergence of curl of vector is equal to 0. CGS curl of gradient of scalar function is equal to how much? 0. Means anything curl of something is equal to 0, always something is equal to negative gradient of scalar function. Okay. Means here is a negative grad phi is equal to 0. Got it? CGS curl of gradient of scalar function. CGS curl of gradient of scalar function. Means curl of negative gradient of phi is equal to how much? 0. Okay. Means curl of E bar is equal to 0 implies that what is the value of E bar? Comparing these two equation. E bar is equal to E bar is equal to negative gradient of scalar function. Negative gradient of scalar function. Okay. And we know that phi del is equal to how much here? Then E is equal to minus dabba phi upon dabba r suppose. is equal to how much? Minus daba 5 potential. 5 is replaced by here V, daba V upon daba. Daba V upon, okay. Means daba V is equal to how much? Minus EDR. Minus EDR. Then what is the value of V? What is the value of V? V is equal to minus integration. EDR. Minus EDR. Okay.
E dot dr.
Minus ED. We know that electric field, minimum electric field. Minimum electric field limits for electric field. Electric field limits. Electric field limits 0 to that point. 0 to that point. Okay. 0 to that point. Okay. Electric field limit. Potential limit. Potential limit. Okay. Electric field limit.
Infinity to that point.
Electric field. Electric field limit. 0 to that point. Okay, 0 to that point. 0 to that point. A is equal to 0 to that point. 0 to that point. Potential. Potential. Suppose charge is here. Charge is here. Potential here. 0 non-zero. Charge on board. Here potential 0 non-zero. Non-zero. Here potential 0 non-zero. Non-zero. Here potential 0 non-zero. Non-zero. We can take 10 kilometer. Potential 0 non-zero. Non-zero. We can take 100 kilometer. Potential 0 non-zero. Non-zero. Yes or no? But we know that at a reference point we need to potential is equal to 0. Yes or no? Means we can take 10 kilometer, 100 kilometer, 1000 kilometer. Potential is not equal to 0. Hence we consider one point where potential is equal to 0. That point is known as infinite point. Yes or no? At infinity, this point. Okay? At infinity. At infinity. Infinity. Potential is equal to how much? Potential is equal to 0. Potential is equal to 0. Got it? At infinity, potential is equal to how much? 0. Okay? We said potential is equal to 0 at infinity. Means this point is known as a reference point. This point is known as a reference point. Got it? This point is known as a reference point. Means lower limit. Potential V is equal to how much? V is equal to minus EDR. Minus integration EDR. Where is the potential is equal to 0? At infinity potential is equal to 0. This point is known as a reference point. Okay? Means a reference point to that point. That point means where we can find out the potential. Okay? A reference point to that point means where we can find out the potential. Next. Suppose charge Q is here. Okay? Charge Q is here. We need to find out what is the potential at this point. What is the potential at point P? What is the potential at point P? Okay? Potential limit. Potential limit.
Reference point to that point.
Okay, reference point to that point. Okay. Okay. Suppose we consider this one is a reference. This one is a reference. This is at infinity. This is at infinity. How much? This potential is equal to how much? 0. Potential is equal to 0. Okay. Where is the point is a reference at infinite distance. Infinity to bring a positive unit charge from this point to this one. This point to this one. On the system, by the system.
On the system.
On the system, sign negative, positive. On the system, negative, positive. On the system, sign positive, negative.
Positive or
Positive. Positive. Positive.
On the systems are negative ಇಲ್ಲ
On the system, by the system. This is for this one. Okay. Now, how to find out the potential? Potential V is equal to integration E dr. Okay. Point into the body, out of the body. Inside the body, outside the body. Point is present inside the body, outside the body. Outside the body. Yes or no? Outside the body, hence we can write down here. Outside electric field. Yes or no? Outside electric field. What is the E out? E out. Because of point charge, electric field outside. KQ upon R square. KQ upon R square into dr. Got it? Outside electric field because of point charge. KQ upon R square simple. Okay, limit. Limit infinity to that point. That point distance. That point distance small r. Okay? Minus. Yes. KQ upon R square integration. KQ minus 1 by R. Limit. Infinity to small r. Infinity to small r. Minus take outside. Minus become plus. KQ. 1 upon R minus 1 upon infinity. 1 upon R minus 1 infinity.
Positive KQ by R.
KQ by R. Here potential is constant variable.
Variable.
Here potential is variable. R is changing. Potential also changing.
Changes.
Here potential is not constant. Here potential is a variable. Okay. Next. Suppose we can take the system is a solid sphere. Yes. Solid sphere. Solid sphere. We can find out the potential at a different point. Suppose first we can find out the V out. This point is here. Point is here. Infinity to that point. Okay. What is the potential? Is equal to minus infinity to that point. Infinity to that point. This distance is smaller or yes or no? This one is a smaller. Electric field we need inside outside on electric field. जितो point आहे तिथलं electric field लागेल आपल्याला. Yes or no? This point is outside the body. Means E out. E out dr. E out dr. Okay. Minus infinity to smaller. E out. KQ by R square into dr. Yes. KQ upon smaller. Second one. Small r is less than capital R. Small r is less than capital R. Okay.
Yes.
Or we can take small r is equal to capital R.
On the surface,
Yes, infinity to that point. That point means on surface. Okay, means there is a capital R. Limit is capital. Okay. V is equal to minus E dr. Here electric field. On out.
on the surface.
ऑन घेता येतं का आपल्याला? ऑन फाइंड आउट करता येतं का आपल्याला? त्यासाठी काय करत असतो आपण? इलेक्ट्रिक फील्ड मात्र कशाचं घेतो? आउटचं घेतो आणि स्मॉल आर इज रिप्लेस्ड बाय कॅपिटल आर लाईक दॅट. ओके. हियर इन्फिनिटी टू capital R minus infinity to capital R. E out KQ upon small r capital R. Small r square dr is equal to how much? KQ upon small r. Limit 0 to capital R. KQ upon capital R. Now each and every point on sphere electric field constant variable.
It's variable. No, it's constant.
This one is constant. R is constant. K constant. Q constant. Next. V in. Okay, this one is a solid sphere. Okay. Infinity to that point. That point to in. Yes. Yes, Bula. Infinity to that point, but here is a two region. Okay, infinity to that point. Okay, actually this to this one, but here is the two part. First this part, second this part. Then v is equal to how much? V in is equal to integration EDR. EDR. This can be converted into two parts. First one infinity to small r EDR.
Small area.
Okay, but we need to convert this into two forms. Yes, infinity to capital R. Infinity to capital R. One region.
Capital.
Infinity to capital R. Electric field. In this region, electric field.
KQ by R square.
KQ by I
E
square.
out. dr minus R2
R2 smaller.
small r.
Small.
In this region, electric field.
In
In this region, electric field in dr. Okay.
DR.
E out. E out.
Q upon R.
KQ upon R square dr minus R2 small r. Yes. In
guys, तिथं असेल KQ upon small r square.
Wait.
Okay. Rho upon
Ro. तो charge this.
ते काढायचं.
Charge this.
yes.
1 upon r. Minus 1 upon r. KQ by minus 1 upon r. Into minus 1 by r.
KQ upon R square.
Minus 1 by r. 0 to r square by 2.
Ro केला. Ro सर नहीं लिहिलं.
ठीक आहे. Here is a row. KQ upon R minus rho upon 3 epsilon naught R square minus okay, this is equal to how much? Rho can be written as K is equal to K Q upon 4 pi epsilon naught R and rho is equal to how much? Rho is equal to Q upon 4 by 3 pi R to the power 3. Yes or no? Into 3 epsilon naught R square minus capital R square. R square minus capital. This 3 get cancel. Okay. Then this is equal to how much? V in is equal to Q by 4 pi epsilon naught R minus Q upon 4 pi R to the power 3 epsilon naught minus become plus Q R square get cancel 4 pi epsilon naught R 4 pi epsilon naught R. Yes or no? 4 pi epsilon naught R. R square by 2. Okay, here 2 also we need to multiply it. 1 by 2. Yes or no? Integration R square by 2. R square by 2. Q by 4 pi epsilon naught. Capital R. 1 plus 1 by 2. 1 plus 1 by 2 plus Q R square upon 4 pi epsilon naught R cube. Dimensionally, this one is correct. Dimensionally, simply Q upon KQ upon R. Yes or no? Means 1 plus 1 by 2. 1 plus 1 by 2. 3Q upon 8 pi epsilon naught R minus K Q R square upon 4 pi epsilon naught R to the power 3. Dimensionally 1 R square get cancelled, 1 by R. Dimensionally correct. Okay. Suppose we can find out what is the potential at center. Potential at center. Yes. Center condition. R is equal to. Center small r is equal to. Center small r is equal to. 0. Means V in or V at center. V at center 3K upon 8 pi epsilon naught capital R. Got it?
Yes, sir.
Yes, in this case, any doubt? Or no doubt? Spherical cell. Rho is equal to K upon R square. Rho is equal to K upon R square. Okay. E1. Inner radius A, outer radius B. Spherical cell. Inner radius A, outer radius B. R1. E1. A1, 0 non-zero. Yes. May I audible? E1. E1 means
Inside inner cell, U1.
Inside I put
R is less than E.
Sir, potential right, the constant potential.
Potential नहीं, electric field.
Electric field 0.
E.
Electric field 0. No
E2.
charge enclosed.
Next, A is less than R is less than B. A is less than R is less than B. चार्ज काय?
आउटर सरफेसवर जातात ना.
नाही इथं कंडक्टिंग सिस्टम नाहीये, डायलेक्ट्रिक सिस्टम
नॉन
आहे.
झिरो सर, नॉन झिरो राहील सर, नॉन झिरो राहील.
व्हॉट इज द व्हॅल्यू ऑफ दिस वन? इलेक्ट्रिक फील्ड व्हॅल्यू
काढावं लागेल.
आर रो अपॉन 3 एप्सिलॉन नॉट.
E2 yes K R minus A upon epsilon naught R square. Epsilon naught R square. What is the value of E3 then? E3 K R minus A is replaced by B minus A.
वैसे
Yes or no? Epsilon naught R square. R square get cancelled. dr integration R limit A to R means R minus A. Second case मध्ये outside ला body limit A to B. R square get cancelled. dr integration R limit B minus A upon epsilon naught R square. Got it? This is the electric field E in out here. Number 1 V out limit infinity to small r, electric field, infinity to small r electric field.
E out.
या रिजन इथे या पॉइंटला इलेक्ट्रिक फील्ड कोणतं असेल? E out dr. What is the E out value? E out means E3 dr. Yes, what is the value of E3? Minus infinity to small r. E3 K B minus A upon epsilon naught R square. Into dr. Yes or no? K B minus A upon epsilon naught R square. Which part we can take common out? Minus K B minus A upon epsilon naught. We can take common out 1 by R square. 1 by R square integration minus 1 by R limit infinity to small r. Minus become plus K B minus A upon epsilon naught R. This outside electric potential is depends upon distance. Next, the second one. Yes, second.
Infinity to smaller. दोन्ही consider E2 E3 दोन्ही घ्यावं लागेल.
किंवा डायरेक्ट आपण V in काढू. V in means where? V in small r is less than A. Yes, here is how many parts then? First limit infinity to B. Next B to A to small r.
Infinite.
Got it? Means V is equal to how much? V is equal to infinity to B. At that time electric field E3 dr minus B to A electric field E2 dr minus A to small r E1 dr. Got it? E3 K B minus A upon epsilon naught R square. K B minus A upon epsilon naught R square into dr. Next, second one. B to A. Yes. Infinity to B. Next, B to A. B to A region electric field means second electric field. K R minus A upon epsilon naught R square. Into dr minus A to small r electric field E1 electric field 0 dr.
0.
Yes or no? Yes. 1 by r square integration. 1 by r square
minus
integration.
1 by r.
K b minus a upon how much? Upon b. Yes or no? First integration value 1 by r square minus 1 by r. Second one. 1 r get cancel. 1 r get cancel. Minus k by epsilon naught. 1 by r integration. 1 by r integration.
ln r, no?
ln r limit b to e.
ln r.
Okay, next. Minus minus become plus. 1 by r square integration. Epsilon naught
minus 1 by r.
minus 1 by r limit. Limit b to a. And the last integration is equal to how much? 0. Last integration 0. Yes, in this case which part get cancelled? या केसमध्ये कोणता पार्ट कॅन्सल होईल? Which part get cancelled?
पहिला आणि लास्टचा का सर?
This part get cancelled, yes.
फर्स्ट अँड थर्ड.
First and third. हे बघा इथं minus a upon b. Then a minus minus become plus a upon b.
सर हे शेवटचं इंटिग्रेशन परत सांगा ना सर, ते समजलं नाही कसं घेतलं.
कोणतं इंटिग्रेशन?
v is equal to minus infinity to b k b minus a epsilon 0 r square dr. तेवढं पहिले टर्मचं समजलं. 1 upon r.
b to
minus 1 upon.
b to a ना?
पहिल्या टर्मचं समजलं, b to a चं समजलं नाही सर, आणि a to r सर.
k r minus a upon epsilon naught r square into dr. Yes or no? K by epsilon naught we can take common out. Integration b to a, splitting this one. 1 r get cancel, means this become 1 by r into dr. Next a la split kara, minus a upon r square into dr. Yes or no? A upon r square into dr. As 1 by r integration ln r limit b to e minus 1 upon r square integration
minus 1 upon r.
minus 1 upon r, and a is outside, limit b to a. Okay, this is equal to how much? K upon epsilon naught ln a upon b, minus minus become plus 1 upon r, a upon r limit b to a. This is equal to how much? K upon epsilon naught ln a upon b. A
Last term sir.
1 upon a
minus
minus 1 upon a minus 1 upon b.
b.
Got it? This is equal to how much? K upon epsilon naught ln a upon b plus 1 minus a upon b.
1b.
Okay.
Okay, sir. Yes, sir.
This one is a k b minus a. याला कसं लिहिता येईल मग आपल्याला? K by epsilon naught b upon b 1 minus a upon b. Got it? हा पहिला पार्ट झाला. 1 minus a upon b into k by epsilon naught. किंवा याला परत सेपरेट मल्टिप्लाय करा k upon epsilon naught. And this part and first part get cancelled. Only which part will be survive? This one. Next, spherical cell. A spherical cell, okay. Spherical cell. This one is empty space, okay. We can find out what is the electric field inside. V in. V in. What is the V in value? V n is equal to, yes, integration infinity to capital R, okay. Infinity to capital R and capital R to small r. Infinity to minus infinity to capital R. At that time, electric field E in, E out.
E out.
E out dr minus R to small r. R to small r at that time electric field E in dr. E in dr. Okay, means V in is equal to S. V in is equal to minus infinity to capital R. V out, E out. KQ by
R square.
dr
Small.
minus R to small r.
Rho R upon 3 epsilon. काय ते? 0. Okay.
System is spherical cell. Spherical inside electric field. Then V in is equal to how much? KQ upon
AQ upon capital R.
V on. V on.
Q by capital R.
KQ by capital R means on spherical cell in on
Equal.
KQ equal.
what is the meaning of that? V is constant everywhere. V is constant everywhere. Yes or no? We can take at the center also. Capital R to 0. Again, we getting potential is same or different? Same, because second part integration is equal to how much? 0. This surface is known as equipotential surface. This surface is known as which surface? Equipotential surface. Equipotential surface means all points we getting potential is equal to how much? 0. Sorry, potential is equal to constant. Whatever we get KQ upon R, we can find out that everywhere we getting KQ upon R value. KQ upon R, KQ upon R. Got it? Next. Here charge is Q1, here charge is Q2. Charge is Q1, Q2. Yes. E1. E1.
0.
E1, 0. Good. E1, 0. Region number 1. Region first. Region second, E2. E2. KQ upon small r square.
R square.
Okay, small r square means region is
1
this.
upon 4.
Region second or region second.
Q1 na sir?
Q1, okay, huh. E3. A3 means Gaussian is here.
Addition.
K
Both addition on both.
Q1
Q1
plus
plus
Q2.
Q2 upon R square.
Region. region third. Okay. Yes, V out. Or directly we can find out the V in. V in.
फी म्हटलं तरी चालेल ना त्याच्यात होऊन जाईल हो.
Infinity to. Infinity to this one. This to this one. This to this. Infinity to minus infinity to infinity to. Mention करो again. Suppose you can say this is the R2 radius. Here is R1 radius. Infinity to R2. Infinity to R2 in this region electric field. E out dr or E third dr minus R2 to R1 E2 dr
E2
R1 to R E1 dr third one infinity
Zero.
to R2 as E out K Q1 plus Q2 upon R square into dr. Next, R2 to R1. R2 to R1. At that time, electric field K Q1 upon R square dr minus 0. Okay? Yes, minus KQ plus K Q1 plus Q2 upon yes R2 upon R2 plus KQ1 1 upon R1 minus 1 upon R2. KQ1 1 upon yes or no? Yes, any doubt? येस या केसमध्ये काय नाही लक्षात आलं और नेक्स्ट रिंग what is the electric field ring Limit. Limit.
Limit scale.
Infinity to that point. Infinity to. Infinity to z. Infinity to z. Means kq z upon z square plus r square bracket is to 3 by 2 into. Here variable is z. Infinity to z. Kq z upon z square plus r square bracket is to 3 by 2. K constant variable. Constant. Minus kq infinity to z. Z upon z square plus r square bracket is to 3 by 2 into dz.
Something upon it.
Yes. Minus kq.
Minus 1 upon
Z square
minus 1 upon z square by r square raised to 1 by 2.
infinity to z. Disk electric field E is equal to sigma by 2 epsilon naught 1 minus z upon z square plus r square. Yes. V is equal to infinity to z sigma upon 2 epsilon naught 1 minus z upon under root z square plus r square z square plus r square bracket complete dz. थोडंसं इंटिग्रेशन सॉल्व करावं लागेल आपल्याला. नेक्स्ट रॉड इलेक्ट्रिक फील्ड E is equal to rod electric field. Rod electric field. Rod means cylinder. Cylinder.
Lambda by 2 pi. Yes, sir.
Lambda by
2 pi rn.
2 pi epsilon naught r E into 2 pi RL is equal to cube epsilon naught. But here system is a 2 q into v. Sorry, rho into v, but here system lambda L system only upon epsilon naught. L get cancel. E is equal to how much? Lambda upon 2 pi epsilon naught r v minus integration infinity to point is here. Okay, infinity to, suppose infinity to small r e dr minus infinity to small r electric field lambda upon 2 pi epsilon naught r dr. Yes. What is this integration value? Yes, what is this integration value? ln r. Then we can substitute the r is equal to infinity. Answer. Yes.
डायरेक्ट मायनस वन बाय आर येईल ना सर ते बाकीचं ते कॉन्स्टंटच आहे
मायनस वन बाय आर कसं येईल ln r येईल ना
इंटिग्रेशन अपॉन लॉग आर
ln r minus 1
सॉरी सर येस सर आर स्क्वेअर नाही देते बरोबर सर ln r येईल बरोबर
आणि ln infinity
ln
infinity
yes it's infinity
मग infinity this one is correct.
नाही सर
ओके लक्षात येते म्हणजे दिस वन इज नॉट करेक्ट. हाऊ टू सॉल्व दिस वन. आता ही जी रॉड आहे हा सिलेंडर आहे आपण कुठपर्यंत एक्सटेंड करू शकतो. दिस इज एक्सटेंड अप टू प्लस इन्फिनिटी टू मायनस इन्फिनिटी. यस ऑर नो. म्हणजे आपली सिस्टमच अप टू इन्फिनिटी पर्यंत जाते तर इन्फिनिटीला पोटेन्शियल 0 असेल का. यस ऑर नो. नो. Yes or no? Then we consider at a point B, potential is equal to 0. येते लक्षामध्ये system itself going to the infinity. Hence we cannot take a reference point at a infinity. Got it? Then we consider at the B, potential is equal to how much? 0. And this point is known as a reference point. Okay? This point is known as a reference point. And we can find out the potential at this r distance. Limit. V is equal to minus integration. Yes. Limit where to where? B to r. E dr minus electric field lambda upon 2 pi epsilon naught r dr. Limit B to r. S. This is how much? Lambda upon 2 pi epsilon naught ln r. Limit b to r. But suppose I consider b is equal to, this is equal to how much? Lambda 2 pi epsilon naught ln r upon b. But we consider b is equal to 1. B is equal to how much? 1. Then b is equal to how much? Lambda upon 2 pi epsilon naught ln r. हे लक्षात आलं का. डोंट टेक हियर इन्फिनिटी फॉर सिलेंडर. For this system we consider a general point where potential is equal to 0. Why we cannot take at infinity potential is equal to 0? Because system itself going to the infinity.
So ये माइनस येईल ना इथं.
How minus it?
सर अशी कंडिशन आहे का बी इज ग्रेटर देन आर असं काही नाही ना.
हा बी ग्रेटरच घ्यावा लागेल ना. बी जर आपण इथे घेतला तर काय होईल?
समजा बी आपल्याला 1 दिला आणि आर जर जास्त दिलं तर
मग हे एक्सपेरिमेंटलीच बरोबर आहे का? एक्सपेरिमेंटली बरोबर आहे का? एक्सपेरिमेंटली बरोबर येईल का हे? आपलं जर डिस्टन्स जिथं फाइंड आउट करतोय बरोबर आहे, तिथं पोटेन्शियल हे जनरली नॉन झिरोच यायला पाहिजे ना. आणि जर आपण तो पॉईंट आधी घेतला तर तिथं पोटेन्शियल झिरो आहे, पण त्याच्या पुढे काय असेल पोटेन्शियल?
झिरोच असेल.
झिरोच असेल, मग ते मिनिंगलेस होईल. लक्षात येत आहे? म्हणजे त्यामुळे आपल्याला ऑटोमॅटिकली हा पॉईंटचं डिस्टन्स जे आहे ते जास्तच असणं गरजेचं आहे. लक्षात येत आहे? नेक्स्ट प्रॉब्लेम. Rho is equal to rho naught r. Rho is equal to rho naught r upon capital R. Upon capital R. Small r is less than or equal to capital R. Small r is less than or equal to capital R. Find out the potential. Find out the potential. V in, V on, V out. V in, V on, V out. Fast. जर आपल्याला व्ही इन व्ही ऑन व्ही आउट जर फाइंड आउट करायचं असेल तर त्याआधी काय फाइंड आउट करावं लागेल? दिस इज अ सॉलिड स्फिअर. ओके, सॉलिड स्फिअर. ओके, सिस्टम इज चलो फाइंड आउट फर्स्ट फाइंड आउट द सिस्टम सॉलिड स्फिअर. फाइंड आउट द ई इन ई ऑन ई आउट. नेक्स्ट व्ही आउट व्ही इन व्ही ऑन. चला करा पटकन. Rho is equal to rho naught 1 minus AR upon R. Okay. Find the magnitude of electric field. Number 1. Find the magnitude of electric field. Magnitude of electric field. Find the magnitude of electric field at R is equal to, at small r is equal to how much? R by 2. Number 1 A. Okay, at R, at small r is equal to capital R. Second one, at what value of R, what value of R is max? Is max. Okay. Here is max. How to find out the electric field? Yes. Electric field. Electric field. EDA is equal to S. EDA is equal to Q enclosed upon epsilon naught. 1 epsilon naught rho into beta. Yes. Yeah. E into
4 pi small r square
is equal to 1 by epsilon
1
naught.
upon epsilon naught.
Rho naught take
Integration
rho
of
naught.
rho naught 1 minus a upon r upon r into d2 r square sin
4 pi r square. Yeah. Okay. 4 pi
okay.
Cancel. E is equal to how much? Rho upon epsilon naught r square. Rho upon epsilon naught r square.
Rho naught, sir, rho naught.
0 to small r. Okay. 0 to
Small r.
R square integration. R to the power 3 upon 3.
3.
r to the power 4 upon
4. 4 into r.
okay 4r.
0 to r. हेच उत्तर आहे थोडक्यात.
Okay, number 1.
पण स्मॉल r स्क्वेअर झालं. ओके.
Small r is equal to
We have to substitute
r by
r by 2, capital R by 2.
a is equal to
Rho naught upon epsilon naught.
r square
R square by 4.
rho naught upon epsilon naught r upon 3
R square. R upon 3.
minus
So R upon 6 होऊन जाईल ना सर ते. Capital R upon 6.
capital r upon 6 कसं आहे?
सर आपण स्मॉल r इज इक्वल टू r by 2 घेतोय ना.
ओके हां मग 6 होईल
R by 6. Yes sir. Capital R by 6.
r square get cancel. Okay, remaining is r square.
Yes.
R square can be written
Yes
as
sir. Capital R square by 4. म्हणजे a capital R square upon 16r.
6.
R get cancel होतं अजून.
Okay, means r by 6 minus r by
Into
6
a sir.
into a. Yes, 8 common घेता येईल आपल्याला.
R upon 2 कॉमन घेता येईल सर.
2 common घ्या. 1 by 3 1 by 8. Yes or no?
1 by 3 1 by 8. Yes sir.
Rho naught upon 2 epsilon naught 1 by 3
R by 2.
minus a by 8
8
outside r.
into R.
Okay, second one r is equal to
सर डिनॉमिनेटर मध्ये नाही, न्यूमरेटर मध्ये राहील सर कॅपिटल.
ओके दोन्ही केस मध्ये न्यूमरेटरला आहे. ओके वरती घेऊ आपण.
यस सर.
टेक न्यूमरेटर. नेक्स्ट स्मॉल r is equal to capital R.
जस्ट सबस्टिट्यूट.
Then a is equal to how much? A is equal to rho naught upon epsilon naught.
Epsilon naught capital R cube upon 3.
R upon 3.
R cube upon
Sorry.
R upon 3. Okay.
A r upon 4.
4. R कॉमन घेऊ शकतो सर.
Next maximum.
What value?
Divide upon divide.
dr is equal to 0.
0.
0 is equal to 0.
What is this integration?
दोघांसाठी काढावं चेक सर.
दोघांसाठी का बरं? जनरल साठी फाइंड आउट करायला लागेल आपल्याला.
जनरल साठी करायचं. ओके सर. ओके सर.
r square cancel. r derivative 1. Okay, means rho r. R also get cancel. Okay, means rho naught upon
Rho naught upon 3 epsilon naught.
rho naught upon 3 epsilon naught minus r square gets cancel. Okay,
Rho
r
naught
square
upon epsilon naught
2 times
2 times a r square small r square upon 4r into epsilon naught आणि वरती into rho naught. So वरती rho naught पण येईल सर.
yes. Which part we can take
Rho
common
naught
out?
epsilon naught cancel. Rho naught epsilon naught get cancel.
Rho naught epsilon naught get cancel. Okay,
Cancelled.
1 to
Yes,
get
sir.
cancel. 1 to get
Right
cancel.
side ला बघा. 1 by 3 is equal
a
to
upon r
1 by 2.
upon 2r is equal to how much? 1 by 3.
1 by 3.
Means r is equal to
So small r is equal to 2r upon 3. 2 capital R upon 3.
upon 3. At this value, electric field is
Maximum.
maximum. 2 r upon 3a. Yes, we can substitute this value in this field. Then we getting a max. Yes or no?
Yes sir.
Electric field is maximum. Sir.
सर ते मागच्या क्वेश्चनचे आन्सर सांगू शकता का सर?
मागच्या क्वेश्चनचे आन्सर V out rho minus a naught square r square चा 2 rho naught a to the power 5 upon 15 epsilon naught r.
वेट सर चेक करू
2 rho naught a to the power 5 upon 15 epsilon naught r.
येस सर ऍप्सिलॉन नॉट आर स्क्वेअर येते सर
r square येतंय का?
हो सर
r यायला पाहिजे पॉवर.
आणि बघा सर 2a⁵
हा.
रो नॉट अपॉन 15 epsilon नॉट इंटू आर स्क्वेअर डिनॉमिनेटर मध्येच आहे. ठीक आहे सर मी एकदा चेक करतो कारण की सर ते 4πr² सोबतच डायरेक्ट आर स्क्वेअर इथे येऊन जातो ना.
About electric field 1 by r square integration.
1/r² 1 minus 1 upon r.
हो ना मग infinity to r.
ओके सर ओके सर इथे आर इज लेस देन ए दिलेलं होतं ना सर कॅपिटल ए स्मॉल ए.
हा V out साठी सांगितलं मी तुम्हाला.
ओके सर येस सर कॅपिटल आर मी ए आउट ची व्हॅल्यू सांगतो सर तुम्हाला. येस सर
बरं.
येस सर करेक्ट आहे.
आणि V in पहिल्या केस साठी रो नॉट r to the power किती येते?
वेट सर सांगतो इनसाइड इन ना सर.
येस.
सर रो नॉट कॅपिटल आर स्क्वेअर अपॉन 3 epsilon नॉट मायनस रो नॉट कॅपिटल आर क्यूब नाही स्मॉल आर क्यूब अपॉन 12 epsilon नॉट कॅपिटल आर.
येस. आलं सगळ्यांचं?
येस सर फक्त ते लिमिट मध्ये थोडासा प्रॉब्लेम होत होता सर.
लिमिट सगळ्यात महत्वाचं लिमिट आहे. एकदा लिमिट तुम्हाला जमलं की पटपट कॅल्क्युलेशन करायला काय अडचण नाही येते केसमध्ये.
सर इनसाइड साठी जर का करायचं असेल तर आपल्याला सर्व लिमिट कन्सिडर करावं लागतात का?
येस. इन्फिनिटी टू दॅट पॉइंट.
इन्फिनिटी टू दॅट पॉइंट पण स्टेप वाईज जावं लागतं.
हो.
ओके सर.
आता त्यानंतर अजून एक बिट क्वेश्चन आहे या केसमध्ये.
ओके सर.
सॉरी. त्यांनी क्वेश्चन्स काय दिला त्या केसमध्ये लास्टमध्ये सबबिट जो आहे तो असा आहे. इफ magnitude of electric field at r by 2 is 1/2 times 1.25 times of at r is equal to capital R, then find out the a value. Means they are given conditions. Which condition? E of at r is equal to how much? R by 2 is equal to 1.25 times of E of r is equal to capital R. Okay. म्हणजे हे दोघांचं रिलेशन काय? E electric field at r by 2 is equal to 1.25 times of E times E at r is equal to how much? R. Finding the which value? Finding या केस मध्ये अननोन व्हॅल्यू काय? A. Finding the A value. What is the value of A? लक्षात येत आहे? Finding the value of A.
सर काही दिलेलं नाही का त्यामध्ये रो वगैरे याच प्रश्नाच विचारतायत का तुम्ही?
हाच बीट नेक्स्ट आहे त्यामधला लास्ट बीट आहे तो.
ओके सर याच प्रश्नामधला.
करता येईल का? चला करा पटकन. हे दोघं इक्वेट करा.
येस सर करता येईल.
हे बघा रो नॉट कॅन्सल होत जाईल. एप्सिलॉन नॉट कॅन्सल होईल.
हो फक्त 1.25 चा डिफरन्स राहील सर त्याच्यामध्ये. येस सर करता येईल.
चलो करा पटकन मग. Or next question. Okay. The electrostatic potential of charge distribution is given by. Charge distribution is given by. They are given charge distribution. Of potential V of R is equal to A e to the power minus lambda R e to the power minus lambda R upon R. Lambda R upon R. Okay, potential is given, find out the electric field. And find the total charge enclosed within the sphere of radius 1 by lambda with its origin at R is equal to 0. Yes?
VR पासून इलेक्ट्रिक फील्ड फाइंड करायची सर आपल्याला.
Yes.
ओके सर, डेरिव्हेटिव्ह घ्यावं लागेल फक्त त्याचं.
चला करा पटकन.
It is 2 minus lambda परत नेगेटिव्ह. ओके ओके ओके. क्वेश्चन.
E is equal to E bar is equal to minus del V. Minus del V. Okay. Minus del. Yes. E to the power minus R upon lambda R upon R. Del V.
सर
E to the power minus lambda R
सर आपल्याला.
minus lambda. Okay. R as it is. Second one minus R derivative 1 e to the power minus lambda R upon
अपॉन R स्क्वेअर.
direction. Direction R क्या? Okay. This is the electric field E bar. Yes sir. Next. We can find out the total charge. Q is equal to E bar dot dA. E bar dot dA. Yes. E bar is equal to minus.
सिस्टम दिलेली का सर काय? सिस्टम वगैरे दिलेली आहे का? कोणती सिस्टम?
नाही सिस्टम आहे ना. सॉरी स्फिअरिकल सिस्टम आहे.
ओके सर. मग डायरेक्ट 4 पाय स्क्वेअर घेऊ शकतो सर आपण त्याचं.
into minus lambda R. Okay. Upon हे मायनस मायनस सगळं प्लस होऊन जाईल, लक्षात घ्या. हे प्लस प्लस प्लस. ओके.
प्लस प्लस
अपॉन
Yes,
R
sir.
स्क्वेअर इंटू R क्या? इंटू एरिया
4 पाय स्क्वेअर.
इंटू एरिया हाउ मच? फोर पाय कसं येईल? एरिया डीए इज इक्वल टू हाऊ मच? जर आपल्याला डीए ला आर कॅप पाहिजे असेल तर कोणते लेंथ एलिमेंट कोणते येतील?
सर क्यू इज इक्वल टू काय घेतलं तुम्ही? ई बार डी ए का?
और ई बार डीए प्लस फाई इज इक्वल टू ई बार डॉट डीए.
सर हे काय बोलले तुम्ही आता? डी इज इक्वल टू ते
डीए बार इज इक्वल टू, जर आर कॅप पाहिजे असेल तर आपल्याला कोणते लेंथ एलिमेंट्स घ्यावे लागतील? डीएल थीटा आणि डीएल फाय. लक्षात येते? डीएल थीटा आणि डीएल फाय घ्यावे लागतील, त्यावेळेस आर कॅप येईल. लक्षात येते? जर थीटा कॅप पाहिजे असेल तर आर आणि थीटा फाय पार्ट घ्यावा लागेल. जर थीटा पाहिजे असेल तर फाय पार्ट पाहिजे असेल तर एल आर आणि थीटावाला पार्ट घ्यावा लागेल. लक्षात येते? त्यावेळेस आर कॅप डॉट आर कॅप 1 येईल. लक्षात येते? म्हणजे डीए इज इक्वल टू डी थीटा पार्ट आर डी थीटा, फाय पार्ट आर साइन थीटा, डी फाय डायरेक्शन आर कॅप. गॉट इट?
आर कॅप
डॉट आर स्क्वेअर
सर एरिया एलिमेंट घ्यायचे असतात ते डायरेक्ट इथे.
साइन थीटा डी थीटा. येस.
एरिया एलिमेंटच घेतले सर आपण.
हो एरियाच घेतला. डी इज इक्वल टू
येस सर. येस सर.
लेंथ इंटू लेंथ एरिया.
येस सर. येस सर. कळालं सर. बरोबर सर. आर स्क्वेअर गेट कॅन्सल हियर.
आर स्क्वेअर गेट कॅन्सल. आर कॅप डॉट आर कॅप 1. Here we can take e to the power minus lambda r common out.
थीटा डी थीटा डी फाय
1 plus 1 plus
1 plus r.
r lambda
Yes, sir.
sin theta d theta d phi.
4 pi.
Okay, this
It's
is
integration.
इंटिग्रेशन कशासाठी इंटिग्रेशन सॉल्व करूनच चालत आहे आपल्याला.
Oh.
ओके हा आता आपल्याला सपोज हे फ्लक्स आहे सपोज असं कन्सिडर करा तर क्यू काढायचे असेल तर कसं घ्यावं लागेल मग phi is equal to q by epsilon naught. Yes or no? Means phi is equal to how much?
Flux.
Epsilon naught.
Just
Epsilon naught.
divide this by epsilon naught.
Phi. Okay, q is equal to how much? Epsilon naught phi. This याला जर epsilon naught मल्टिप्लाय केलं तर आपल्याला काय मिळेल हा चार्ज मिळेल. ओके आणि त्यांनी विचारलंय की लॅम्बडा इज इक्वल सॉरी r is equal to 1 by lambda ला फाइंड आउट करायचं आहे. r is equal to 1 by lambda. What is the value of q at r is equal to 1 by lambda?
What is the value of q at r is equal to 1 by lambda?
Yes, what is the answer?
Eight pi epsilon naught upon e.
Next problem. Answer is 8 pi epsilon naught upon e. 8 pi epsilon naught a upon e. 8 pi epsilon naught.
Upon e. Yes.
हे आपला कुठे गेला हे घेतलाच नाही ठीक आहे नो प्रॉब्लेम. नेक्स्ट प्रॉब्लेम. A static charge distribution rise the electric field. A static charge distribution rise to an electric field of form E bar is equal to alpha 1 minus e to the power minus small r upon capital R. Minus small r upon capital R. R cap upon R square. R cap upon R square. Find the charge within the sphere of radius R. Center at origin. Center at origin. काय फाइंड आउट करायचं आपल्याला? Find the charge. Okay. Then charge. How to find out the charge?
पहिले फाय काढावं लागेल आणि फाय चार्ज इज इक्वल टू 5 into epsilon naught.
डायरेक्ट क्यू घेतलं तर चालेल का? क्यू टोटल इज इक्वल टू
घेऊ शकतो सर.
एप्सिलॉन नॉट
epsilon naught into integration of e into ds.
or we can take phi. Yes, into phi. Yes, phi is equal to phi integration
E into ds. Integration of e
e
into
bar
ds.
dot dA bar a bar dot dA bar epsilon naught. Okay, what is the value of e bar? This is a repeated question.
Alpha into
नेटला पण
minus.
विचारला हा क्वेश्चन, जेस्टला पण विचारलेला क्वेश्चन आहे हा. येस ई बार अल्फा
Alpha into 1 minus e
e
raised
to
to
the power
r upon capital R.
capital R
R upon capital R.
r cap upon r square. R cap upon r square. Dot
आता परत डी
dot dA. dA बार
आर डी थिटा साइन थिटा डी फाय
म्हणजे आपल्याला इथं कोणता कॅप लागेल?
आर कॅप
आर कॅप. म्हणजे लेंथ एलिमेंट कोणते लागतील? लेंथ एलिमेंट
आर डी थिटा
आर डी थिटा
आर साइन थिटा
r sin theta d phi. R sin theta there. Then only getting r cap 1. Okay, r square get cancel. Which part we can take common out?
4 पाय आर स्क्वेअर पण डायरेक्ट किती घेतलं तर त्याचे तर सर आन्सर
कसं काय?
बघा ना सर आर डी थिटा साइन थिटा डी फायचं 4 पाय येतं उत्तर.
हे
आणि
कधी?
r स्क्वेअर तिथे
हे कधी? जर आपला इलेक्ट्रिक फील्ड डज नॉट डिपेंड्स अपॉन थीटा अँड फाय.
ओके सर. आणि जर का थिटा आणि करेक्ट सर थिटा आणि फायवर गोंधळ होईल. ओके ओके सर.
Okay, net 3.5 marks and just also 3 marks problem. 4 pi epsilon naught 1 minus e to the power minus small r upon capital R. This is the value of Q total. At what value? At capital R value. Yes or no? At capital R value, total कुठे येईल? Small r is equal to capital R. Total charge कुठे येईल? Yes or no? Total charge on surface means small r is equal
Yes
to
sir. E raised to power minus 1
means 1 minus
small 1
1 minus 1 by 1
e
minus
raised to minus
next
1 minus e raised to power minus 1.
next problem. E bar is equal to E of R is equal to E of R is equal to E of R is equal to alpha r cap plus beta sin theta cos phi beta sin theta cos phi sin theta cos phi phi cap. Okay, exist in space. This is the electric field exists in a space. Okay. What will be total charge enclosed in sphere of unit radius centered at the origin? Centered at the origin. Electric field E of R is equal to alpha r cap
Alpha r cap
beta sin theta cos phi phi cap exists in space. What will be total charge enclosed in a sphere of unit radius centered at origin? Centered at
सर आता इथं दोन प्रकारचे हॅलो सर
दोन प्रकारचे आहेत. बरोबर आहे.
हा तर मग आता इथं आर कॅप वाला आणि फाय कॅप वाला साठी दोन वेगवेगळ्या प्रकारचे इंटिग्रेशन सॉल्व्ह करावं लागेल कसं राहते
नाही एकच सॉल्व्ह करावं लागेल. कोणता? इलेक्ट्रिक फील्ड इज अ फंक्शन ऑफ
थिटा साइन थिटा
इलेक्ट्रिक फील्ड इज अ फंक्शन ऑफ R.
थिटा साइन थिटा cos थिटा आणि
E ऑफ R दिलाय त्यांनी.
हा हा
ओके. तर दुसरी गोष्ट आपल्याला लक्षात आलं पाहिजे की आन्सर कोणत्या फॉर्म मध्ये आहे. E ऑफ R ओके डॉट
dr
E बार डॉट dA R स्क्वेअर
साइन स्क्वेअर
sin theta
साइन थिटा
d theta
d theta
d
d
phi
phi
r
d
cap.
phi
यस. यामधला कोणता पार्ट सर्वाइव्ह होईल? ए वाला बी वाला अल्फा बीटा
बी बी वाला अवॉइड होईल म्हणजे निघून जाईल बीटा वाला
दिस इज इक्वल टू हाउ मच 4 पाय
ओहो
4 पाय
4 पाय
अल्फा
अल्फा आर आर
अल्फा
नाही बस थांबा 4 पाय बस अल्फा इनटू कॅपिटल आर एप्सिलॉन 4 पाय
गॉट इट. Yes, in this case, any doubt?
R³ by 3 आहे ना.
R cube by 3 कसं येईल? Not with respect to R आहे आपला.
हो 4 पाय ला म्हणतो सर. मग ते R स्क्वेअरचं काय झालं? हा तोच कॅपिटल R म्हणून घेतला. ओके सर.
मग तो R स्क्वेअर का गायब झाला पुढे?
स्मॉल आर साठी सर
हो, स्मॉल आरचा कॅपिटल आर झाला, नो प्रॉब्लेम. कॅपिटल आरचा परत
गायब कसं काय झालं? बरोबर.
लास्ट सेंटेन्स.
युनिट रेडियस.
What will be total charge enclosed in sphere of unit radius center at the origin? म्हणजे ओरिजिन सेंटरला आहे आणि युनिट रेडियस आहे, म्हणजे R इज इक्वल टू 1 आला.
येस सर. ओके सर.
नेक्स्ट. V of x is equal to 3x square. हा बोला.
सर जर काही ई थीटा सांगितलं असतं तर फक्त आपल्याला बेटाची टर्म घ्यावी लागली असते का?
येस. ही थीटा किंवा सेकंड वन तुम्ही आन्सर म्हणून एक डिसाइड करू शकता.
ओके सर. ओके सर. इतक्या छोट्या छोट्या गोष्टींकडे लक्ष देत नाही ना सर, त्याच्यामुळे
नाही, दोन्ही आले म्हणजे दोन्ही घेतले तर मग तो एरिया कसा होईल? x, y. 3x square minus 3y square. 3x square minus 3y square. Okay. The electrostatic potential V of x, y in some region is given by V of x, y is equal to 3x square minus 3y square. Find the charge density.
सर इथे अगोदर ई फाइंड करून मग रो फाइंड करावं लागेल ना.
पोटेन्शियल आणि चार्ज डेन्सिटी साठी फॉर्म्युला आहे सर.
This equation is known as. This equation is known as Poisson's equation, and del square V is equal to 0. Then what is Euler rho? Epsilon naught 2 minus 2. Find the x and y component. Find the x and y component. X and y component. Find the x and y component of the electric field at the origin. Of the electric field at origin. Electric field at origin. Electric field at origin. Origin xy. Potential is this one. Then what is the electric field? Ex component. Ex is equal to minus del V. Yes or no? Then Ex is equal to how much? Ex is equal to minus dabba V upon dabba x. Yes or no? Minus dabba V upon dabba x is equal to how much? Is equal to minus
6x minus 6x
minus 6x. But at origin
x is equal to 0.
x is equal to 0, y is equal to 0.
Is equal to 0.
Minus 6 into 0 is equal to 0. Ey is equal to minus del y, del v. Ey is equal to minus dabba v upon dabba y.
6
Minus 6y.
at origin 0.
Or minus no, plus 6y.
6y. Yes sir.
And then Ey at
And
origin
origin is equal to 0.
0, 0, 0. Got it? Next. Next problem. if the electrostatic potential in spherical coordinate phi of r is equal to phi of r is equal to phi of r is equal to this also net problem. Phi of r is equal to phi naught e to the power minus r upon e to the power minus r upon r naught minus r upon r naught phi naught, where phi naught and r naught are constant. Phi naught and r naught are constant. Okay, phi naught and r naught are constant. Okay. Find the charge density. Find the charge density. Charge density at r is equal to how much? R naught. At r is equal to how much? R naught. Find the charge density at r is equal to r naught. Charge density and potential relation. Charge density and potential relation.
Del square is equal to minus rho upon epsilon.
Then what is the value of del square? Del square phi is equal to 1 by r square dava upon dava r square dava phi upon dava r. Actually, that is one is a del square. Got it? 1 by r square dava upon dava r square dava phi upon dava r. Phi is the scalar potential. 1 by r square dava upon dava r square. R square derivative.
2r.
मग किती होईल? 2r झालं घेतलं तर
2r घेतलं तर 1 upon r.
चालेल का?
1 upon r.
phi naught e to the power minus r upon r naught. तसं घेता येणार लक्षात ठेवा. r square चं कधी डेरिव्हेटिव्ह घ्यायचं नाही. फर्स्ट सॉल्व डबा पाय अपॉन डबा r. 1 by r square
Yes, sir. Yes, sir.
1 by r square डबा upon डबा r square.
By dou r.
Phi naught e to the power minus r upon r naught.
Phi naught e raised to power minus r upon r naught into 1 upon r naught minus 1 upon r naught.
Okay. Next.
आता क्वेश्चन टू वापरावं लागेल सजेशन.
Phi naught
Phi naught upon minus phi naught upon r square r naught. R square r naught.
डबा upon डबा r square
e raised to power minus r naught r upon r naught into minus r naught म्हणजे minus 1 upon r naught.
घेतलं ना पुढे आपण इव्हेंट टू
समजा आता क्वेश्चन टू वापरावं लागेल.
हा
क्वेश्चन टू वापरून सांगत होतो सर मी डायरेक्ट.
ओके हा बोला. This is equal to how much? Phi naught r naught r square
r square
डबा upon डबा r square e to the power minus
okay sir r naught
r square
r square or e raised to power number पहिला is it plus r square e raised to power minus r naught upon r into minus 1 upon r naught.
Find out the row at
R
r is equal to r naught. R is equal to r naught means minus phi naught upon r naught square
r naught cube
2r naught
2
e to the
e raised to
power
power minus 1
r naught
plus
square
r naught square r naught होऊन जाईल सर डायरेक्ट r naught कॅन्सल
e to the power minus
minus
r naught cancel. E raised to power minus 1 common issue. R naught common. E raised to power minus 1 common. 2 upon 2 minus 1. Okay. Q naught upon R naught square e raised to power minus 1.
square phi is equal to 1 over r square d by dr r square d phi by dr म्हणजेच रो का?
यस, कोणता फॉर्म्युला?
अजून कोणाला लिहिलाय phi is equal to 1 over r square d by dr
हा दिस
r square d phi by म्हणजेच रो का सर?
सर ते याचं येतं सर, लॅप्लाशियन ऑपरेटर येते, त्याचा फॉर्म्युला एक स्टँडर्ड फॉर्म्युला वेगळा असतो, पण आपण जी सिस्टीम घेतलेली ना, ती सॉलिड स्पेअरची सिस्टीम घेतलेली, त्याच्यामुळे त्याचा फॉर्म असा आहे. तो लॅप्लाशियन ऑपरेटरचाच फॉर्म्युला वेगळा आहे सर एक.
म्हणजे तो रोच्या इक्वल आहे का तो फॉर्म्युला?
सर आता सध्या तरी हाच वापरावा लागेल, म्हणजे तो त्याचा स्टँडर्ड फॉर्म्युला वेगळा आहे. आता हे सॉलिड दिलेली ना, म्हणून त्याचा हा या रूपात येतो, याचाच फायदा होतो आपल्याला याच्यामध्ये.
or
येस सर.
okay, next we can take the two parallel plates of parallel plate capacitor which are in normal to the x-axis are located at x is equal to 0 and x is equal to 2a. X is equal to 0 and x is equal to 2a. The plate at x is equal to 0 is grounded while other plate is at potential V0. The space between two plates has uniform volume charge density rho. Okay. Problem. There is a two parallel plate. First plate, second plate. Okay. Grounds, lower plate is grounded. Yes, sir. Lower plate is grounded, and the second plate have at x is equal to 0. At x is equal to 0, this plate is grounded. X is equal to 0, plate is grounded, and x is equal to 2a plate is having potential V0. Okay. And here uniform charge density in between, uniform charge density rho. Find the potential between these plates. Find the potential between these two plates. Yes, potential and rho relation. Here x are given, means system.
1D.
Means here we can use the Cartesian system. Yes or no? Del square is equal to how much? Del square v is equal to dabba square v upon dabba x square plus dabba square v upon dabba y square plus dabba square v upon dabba z square. Yes or no? But here x is a variable, then neglect second and third part. Means the del square v is equal to simply dabba square v upon dabba x square is equal to how much? Minus rho by epsilon naught. Yes or no? Minus rho by epsilon naught. Means dabba square v upon dabba x square is equal to how much? Dabba upon dabba x. Dabba v upon dabba x is equal to how much? Minus rho by epsilon naught. Our aim to finding the potential. How to find out the potential? Integration. Yes. Integration. Dabba v upon dabba x is equal to how much? Minus rho upon epsilon naught dx plus some constant a. Yes or no? Some constant a. Take integration on both sides. Derivative integration get cancelled. Means dabba v upon dabba x is equal to how much? Dabba v upon dabba x. Dx integration x. Means this is equal to how much? Minus rho x upon epsilon naught plus a. Okay. Next. Dabba v integration. Take second integration. minus rho x upon epsilon naught plus a bracket complete dx plus b. Suppose we can take the second constant. Yes, minus rho by epsilon naught, take common out. X integration x square by 2 a into dx ax plus b. What is the potential v? Potential v is equal to how much? Minus rho x square upon 2 epsilon naught minus rho x square upon 2 epsilon naught plus ax plus b. Okay, they are given some condition. The equation need to solve the following boundary condition. Polar boundary condition, yes. Then you find the potential between these two plates. Okay, x is equal to 0, v is equal to x is equal to 0, v is equal to at x is equal to 0 potential
V is equal to B. V is equal
x
to
is equal to 0. What is the potential on grounded plate?
ಇಲ್ಲ ಸರ್
0. Yes or no? Grounded potential is equal to how much? 0. Implies constant. कोणता कॉन्स्टंट मिळेल आपल्याला फर्स्ट बाउंड्री कंडिशन वरून?
सेकंड कॉन्स्टंट मिळेल.
ओके, व्हाट इज द वैल्यू ऑफ बी?
b equal to 0.
B is equal to 0.
B is equal to 0.
b is equal to 0 and at x is equal to 2a.
At x is equal to a. B जर का 0 असेल. सर v of a काय आहे का?
Second constant no.
हा सेकंड कॉन्स्टंट मिळेल.
Yes or no? At x is equal to boundary. First boundary at x is equal to 0. At x is equal to 0. What is the potential on grounded plate? Potential v is equal to 0. Yes or no? Means 0 is equal to, yes, 0 plus b implies that b is equal to 0. Yes or no? b is equal to 0. Second one, at x is equal to 2a. At x is equal to 2a. At x is equal to 2a, potential v is equal to how much? v naught. Okay, then v naught is equal to, yes, minus rho upon 2 epsilon naught x square means 2a bracket square means this is a 4a square plus a x means 2a plus b is equal to how much? 0. Yes or no? Our aim to finding the a value. Here minus going to this side, this become plus, this become 2a. This is v naught plus rho 2 rho a upon epsilon naught into 2a. This is the value of a. Then what is the value of potential? V of x is equal to minus rho x square upon 2 epsilon
By 2a.
plus here is a multiplied going to this side, divide. Okay, 1 upon 2a v naught plus 2 rho a upon epsilon naught plus b. What is the value of b?
X.
b is equal to 0. This is the
Sir
potential.
into x पडेल ना.
Okay, into x. First मध्ये x square,
Sir, x.
second मध्ये x
x
square.
पडेल.
Next. Next, find out the electric field of E of x. E of x. E of x.
Minus 10v. Minus 10v.
Minus, चलो करो find out fast.
हॅलो सर.
हाँ बोला.
सर हा क्वेश्चन होता कसा म्हणजे नेमका?
आता यामध्ये दोन प्लेट दिल्यात आपल्याला, पॅरलल प्लेट ऑफ कॅपॅसिटर,
ओके सर.
आणि त्यांनी विचारलं फाइंड आउट द पोटेन्शियल, फाइंड आउट द इलेक्ट्रिक
सर
फील्ड.
गिवन डेटा नव्हता का?
आहे ना डाटा, हे काय हाच दिला, नेक्स्ट इज इक्वल टू
ओके
0.
ओके सर. ओके सर. सर ते डेल स्क्वेअर व्ही ची व्हॅल्यू डायरेक्ट रो बाय एप्सिलॉन नॉट कशी आली तेच?
नाही हा फॉर्म्युलाच आहे, डेल स्क्वेअर व्ही इज इक्वल टू मायनस रो बाय एप्सिलॉन नॉट पॉइजन, आणि लॅपलास डेल स्क्वेअर व्ही इज इक्वल टू 0.
येस सर. येस सर.
Rho is equal to rho naught 1 minus r upon r square. R is less than or equal to capital R. Find out the potential inside, outside, on. Inside, outside, on. Rho is equal to how much? Rho naught 1 minus small r upon capital R. Small r is less than or equal to capital.
हॅलो सर.
Yes.
सर प्लीज ते क्लासिकलचे आणि क्वांटमचे रिमेनिंग जे व्हिडिओज आहेत ना सर, ते अपलोड करा ना.
Yes, what is this electric field? In, on, out. Electric field. First find out the electric